to see what this looks like, let's make a chart of numbers and see what happens. So we're going to start with 0. You know, normally when we start graphing, we do some negatives, some positives. But let's start with 0, and we're going to use our unit circle. We'll go from 0 all the way to 360 degrees or 2 pi. We're going to do everything in radians. With graphing, we typically deal with our angles in radians. So we are going to do between 0 and 2 pi. So right here, this is going to be 0. I'm going to put a 2 pi over here, and we'll kind of split it up. It's kind of like we split up the unit circle. Let's do that. Halfway would be pi. Half of that would be pi over 2. And in between there, we've got our other important angles. Pi over 6, pi over 4, pi over 3. I'll throw in pi over 4. And then you can know that looking at the unit circle, pi over 6 and pi over 3 are in between. Right here, 3 pi over 4. Between pi and 2 pi, it's going to be 3 pi over 2. In between that, we've got our other angles. Halfway between pi and 3 pi over 2 is, let's see, that'd be 1/4, 2/4, 3/4, 4/4, 5/4. 5 pi over 4. And then 6/4, 7/4. Between 3 pi over 2 and 2 pi. Okay, so these are some of the values we'll figure out. So when we do sine of any of our angles is always on our unit circle, the y coordinate, remember. So we're looking for whatever the y coordinate on the unit circle is. This is the y coordinate on the unit circle. So sine of 0, at 0 degrees or 0 radians, we have a value of 0. How about at the next one, pi over 6? We're going to do every angle in our first quadrant, the ones on the unit circle. So at pi over 6, sine is 1/2. You know, and if we check this out in our calculator, maybe if we're in degree mode, we would punch in sine 30, we would get 0.5. Pi over 4 is going to be root 2 over 2. Now since we're graphing this, I'm going to jot down the approximation, 0.707. Then pi over 3 is going to be root 3 over 2, which is approximately 0.866. And then let's fit one more in here. How about at pi over 2? That'll give us our whole first quadrant. At pi over 2, sine is 1. The y value is 1. And again, you can check any of these in your calculator. Sine of 90 degrees, you're going to get 1. So let's plot these and see what's starting to happen. So 0, 0. And it looks like the highest I'm going to go is 1 at this point. Actually, that's going to be over the whole thing. The highest y value is going to be 1. The lowest is going to be -1. So at pi over 6, I'm at 1/2. Pi over 4, I'm up a little bit, 0.7. The next one, pi over 3, I'm at 0.866. And then pi over 2, I'm at 1. So, and this is going to be kind of curved like that. So now when I go over to the quadrant 2, let's get some more values. Let's jump over to the 3 pi over 4. So at 3 pi over 4, the y value, well, that's the same as what it was at pi over 4. It's a positive root 2 over 2. 0.707. How about at pi? So at pi, the y value is 0. So let's see what's going to happen there. 3 pi over 4, I'm at 0.707. And then at pi, I'm at 0. So this is going to come back down. We can kind of imagine the points in between too. We're going, the y values are going from 1 down to 0 as we move down towards, as we get to pi, we're going y values from 1 to 0. So it's going here from 1 down to 0. So now when we go down into quadrant 3, so notice too, I'm kind of doing this split up into quadrants. Quadrant 1, quadrant 2, quadrant 3, quadrant 4. So now in quadrant 3, let's do 5 pi over 4. So now, down here at 5 pi over 4, my y value, remember sine is y, is a negative root 2 over 2. So negative 0.707. And then at 3 pi over 2, so down here at 3 pi over 2, my y value is negative 1. So 5 pi over 4 is negative root 2 over 2. 3 pi over 2, I'm going to hit down at negative 1. So this is going to curve like that. And you can kind of probably imagine at 7 pi over 4, I'm at, again, negative 0.707 approximately. And then at 2 pi, my y value is back to 0. Okay. Now if I kept going, now I would be at, let's say just right here. That would be, so I've been a full 2 pi, which is 8 pi over 4, 9 pi over 4. What would 9 pi over 4 be? Well, that would be back to a positive 0.707. So you can see it's just going to continue like this. Same going the negative direction. If I did, let's say over here, let's just do negative pi over 2. Negative pi over 2, the y value is a negative 1. So you see this continue down that way. So it's going to be, it's cyclical, the same pattern. So what I just have here in bolded black though, this is called 1 period. This is 1 period of sine of x. The other thing I want to point out is some key points. So notice, I start off here at a y value of 0, then I go up to 1, that's my peak, and then I go through 0 again, hit 1 is a, negative 1 is a low y value, and then back up to 0. So that the sine wave is always going to kind of have 5 key points like that. 0, max, 0, min, 0. So those are the 5 key points. So 5 key points. Okay, so that is sine of x. Notice too that the domain, what are the x's that we can have? We can plug in any angle of x. So let me put it over here. So the domain is negative infinity to infinity. The range though, if we look bottom to top, we have no points until we hit negative 1, and then there's values until we hit a positive 1. And those are points included, so we would use a bracket. Okay, so now let's do cosine. Okay. Keep my unit circle up. So now cosine, graph of y equals cosine of x. So I'm going to do the same thing. I'm going to kind of split up between 0 and 2 pi. Halfway is pi. Pi over 2. 3 pi over 2. And then in between, I'm just going to put my quarters in between this time. You'll probably see the pattern a little quicker this time. So I've got pi over 4. So that was 1/4, 2/4, 3/4, 3 pi over 4, 4/4, 5/4, 6, 7/4, 7 pi over 4. 8/4 would be back to 2 pi. Full time around the unit circle. So now, cosine of x on the unit circle, cosine, remember these are the x values on the unit circle. These are the x values. So as we're looking around the unit circle, when I'm doing cosine of, we'll start with 0 radians. Cosine of 0, we're looking at the x, the x value, 1. Or how about pi over 4? Cosine of pi over 4, cosine of 45 degrees is square root of 2 over 2, or 0.707. Pi over 2 is x value of 0. So notice, it's all of these x values. So if we start off in quadrant 1, starting off right here, got our quadrant 1 values. So at 0, that y value is a positive 1. We start off at 1. Pi over 4, now it's at 0.707. And then at pi over 2, we're at 0. And if we kind of, let's just plot in, didn't write them in here, but the square root of 3 over 2 at 30 degrees, that would have been right here. Half right here. And see, I'm not drawing it too accurately. What it looks like is actually curving like this. Okay, so it kind of starts off and then decreases a little quicker. So then let's go into quadrant 2. So now how about 3 pi over 4? So at 3 pi over 4, the x value, and now look at the x values, would be a negative 0.707. And then at pi, the x value would be negative 1. So that kind of makes sense because at 3 pi over 4, we're down at negative 0.707. At pi, we hit negative 1. So like that. Then at down here at 5 pi over 4, our x value is still a negative. Cosine is still negative, so negative 0.707. At 3 pi over 2, the x value is 0. 7 pi over 4. Right, now we're back to x values being positive. So notice, once we hit that, that 0, so 5 pi over 4 is negative 7.7, 3 pi over 2 is 0. Okay. My x values are going from negative in quadrant 3 to positive in quadrant 4. So now it's going to come back above the x-axis. So it's going to be a positive 0.707. And back to 2 pi, and back to a x value of, or y value, sorry, of 1. The graph's getting a little bit into my points. Like that. Okay, now from here it would continue. See, right now I start at 1, go down, and then back up. It would continue down, back up. Same in this direction. Again, 1 period. 2 pi is 1 period of cosine of x. 1 period right there. Domain and range are going to be the same as sine. Domain, you can put in any x, but the y values would have to be between negative 1 and 1. And then again, my 5 key points. In this time, I start up at 1, then I have a 0, low point at negative 1, 0, end up at 1. So that's for cosine. So notice, it has the same pattern. It's more just kind of a matter of where it starts.